Hey class, in this video, I am going to go through all of the problems that were assigned on page 48, 5 to 22 all. So if you have any trouble on any of the questions, all you need to do is fast forward to the question that you need, watch me work it out for you, and you should be all good to go. Here we go, number 5. 5 is asking us to find the value of the power 2 to the third. So that means we need to multiply 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Number 6. Now we're going to find the value of 15 to the second. So I'm not going to show you the multiplication because I know you can do that on your own. So what this question is asking us to do is 15 times 15. Be careful with that. When we work out the multiplication, we come up with 225. Number 7, 5 to the fourth. So that exponent tells us how many times to use the base. 1, 2, 3, 4. And we work it out. 5 times 5 is 25. 25 times 5 is 125, and 125 times 5 is 625. Number 8. So when it says evaluate the expression, we need to make sure that we apply our order of operations to simplify it to one number. And we need to make sure that we show our mathematical proof one step at a time. So if I were to write out the order of operations, this is what we would follow. There are no parentheses. There are no exponents. There is multiplication and division, and we work that from left to right. 11 times 8 is 88. Whoops, and I wrote 86. Whoopsies. See, we all make whoopsies. 88 minus 6 divided by 2. We still have multiplication and division, so that needs to be solved next. So then we would have 6 divided by 2 is 3. Then we would do our subtraction, 88 minus 3, and that's how we arrive at 85. Okay? Let's do number 9. Move you down a little bit. Okay, number 9, 5 plus 2 to the third divided by 4 minus 2. Again, we don't have any parentheses, so exponents would come next. 2 to the third means 2 times 2 times 2, which is 8. So then I'm going to drop down the 5, the plus, the divide by 4, and the minus 2. We don't have any more exponents, so we go to multiplication and division next. 8 divided by 4 is 2. Drop down the rest of the problem. And then addition and subtraction gets worked out from left to right. 5 plus 2 is 7. 7 minus 2 is 5. All right, on to number 10. Move my paper up a little bit. All right, 10. 6 plus 4, parenthesis, 11 minus 2, close parenthesis, ooh, long one, divided by 3 squared. Okay, so let's start at the top of our list. We do have parentheses, so let's solve that first. 11 minus 2 is 9. Now, these were smashed together. When they're smashed together, that means multiplication. So I'm going to plug in a multiplication symbol. Drop down the rest of my expression. Whoops, 3 squared. Okay, so I don't have any more parentheses, so next I'm going to do exponents. That's second on my list. 3 squared is 9. 3 times 3 is 9. Drop the rest down. 6 plus 4 times 9 divided by 9. So from here, I'm going to work multiplication and division from left to right. So the next thing I need to work out is my multiplication. So drop down the 6, drop down the plus. 4 times 9 is 36. Drop in the divide by 9. Then I have just addition and division. Well, division comes first. 36 divided by 9 is 4. Drop down the 6 and the plus, and 6 plus 4 is how we're going to arrive at 10. So one step at a time. You may want to just work out or write out that PEMDAS for you off to the side. Okay, I need a new page. Move you up again. Okay, number 11. Okay, so for 11 and 12, we're simply listing the factor pairs for the numbers provided. And you can do this in a factor rainbow if you want, that would be totally fine. Or you can simply list them together, which is what I'm gonna do. So 1 and 52 is a factor pair because when I multiply them together, I get 52. 2 times 26 is another factor pair because when I multiply those two together, I get 52. And 4 times 13 also gets me to 52. So those are my only factor pairs. Number 12, same idea, but now we have 66. So we can always start with 1 and the number. That's our first factor pair. Well, it's even, so I know it's divided by 2. So 2 and 33. I know it's divisible by 3 since 6 and 6 are both divisible by 3. So 3 and 22. And then I know since it's a repeating digit, it's divisible by 11. So 6 and 11 is my last factor pair. Okay, and factor pairs are really setting this up for prime factorization, which we're gonna do in number 13. So for 13, we're doing the prime factorization of 46. So we're gonna start by doing a factor tree. Any two numbers that multiply together to get 46 is a good choice. Well, I know this is even, so I know it's divisible by 2. 2 times 23 gets me to 46. Now we're going to analyze our new factors. 2 is prime, it gets a circle. 23 is also prime. So you don't have prime factorization yet. Prime factorization shows a number as a product of its prime numbers. So we have to put a multiplication symbol in between those prime numbers. They should be listed from least to greatest. Okay, so there's our prime factorization. 14. Okay, same directions. Now it gives us a new number, 28. And we have options. I can do 4 and 7. I can do 2 and 14. Doesn't matter. Let's do 4 and 7 and analyze our new numbers. 7 is prime. It gets a circle. 4 is not prime. 4 can be divided or broken up into 2 times 2. These 2's are both prime. So then we take our prime numbers off the tree. I like to do at least to greatest right away. So I have 2 2's and I have a 7. I have multiplication symbols in between, not done quite yet. I have repeated factors, so I have to use a power to express repeated factors. Don't forget that multiplication sign in between. So we have 2 squared times 7. Okay? All right, let's look at number 15. 15 asks us for the GCF, greatest common factor, using lists of factors. And we talked about in our lesson, you can use whatever strategy you want. I don't like to just list factors, so I'm not going to show that strategy. I don't think it's very effective. So my numbers are 24 and 54. Okay, now I prefer the ladder method You can choose whatever method you want. So you can choose 2 goes into these. You can choose 3 goes into both of these. You can even choose 6 right away if you see it. 6 to me is really popping out. So I'm going to say 6 goes into 24 4 times. 6 goes into 54 9 times. Then I analyze my new numbers, 4 and 9. There isn't another factor that goes into both of them other than 1, which means 6 is my greatest common factor. Okay, if you chose 2 or 3 to begin with, you would just need another rung in your ladder. Okay, let's look at 16. Same idea for 16, but now they give us 3 numbers. So 16 and 32 and 72. Okay, so from here, you may not easily see what numbers go into all of these, okay? So maybe you want to start with just 2, and you would say, okay, 2 goes into 16 8 times. 2 goes into 32 16 times. And then you can figure out 2 into 72. If you don't know 2 into 72, well, we know it's even. So if you're unsure, let me just tell you, there's no harm in just setting it up this way. Okay, and then you can just work out that division real quick. 2 goes into 7 3 times. At 6, subtract, I get 1. 2 goes into 12 6 times. And I'm showing you that because sometimes we need to work out that division just to see what else is a factor, or what how many times our factor goes in, I should say. Okay, let's try it again. I know that these are all even, so I know 2 goes in. You might see right away that 4 goes in, and that would be a good choice, but there's no harm in picking 2 again if you need to. 4 goes into 8 twice. 4 goes into 16 4 times. And 4 goes into 36 9 times. From here, there are no other factors that go into all 3 of them, except for 1. So we draw a G around our common factors, and we multiply those common factors. And 2 times 4 is 8, which means 8 is our greatest common factor. Okay, let's look at number 17. Okay, 17, GCF again, of 52 and 65. Draw our ladder. I'm always going to show the ladder method, but you can use whatever method that you choose, okay? Now, this one's a little tricky, 52 and 65. We know 2 doesn't go in. I'm starting with my smallest prime numbers. 3 won't go in. 5 doesn't work for 52. 7 doesn't work. 11 doesn't work. So the next prime number I'm going to try is 13. And I know that 13 goes into both of these. It goes into 52 4 times and into 65 5 times. And if you didn't know that, maybe try to get into the habit of trying all those small prime numbers. Okay, there's no other common factor, so 13 is our GCF. There's a trash truck outside. Let me try to talk loud for us. Number 18. 18, 45, and 63. So right away I recognize 9 as a common factor. It goes into 18 twice. It goes into 45 5 times and into 63 7 times. There's no other common factor, so 9 is the GCF. Okay? All right, the rest we're gonna show LCM. So 19 Again, we're gonna choose any method. 14 and 21. So listing multiples is fine if you're given small numbers, but I think that it can become really cumbersome when those numbers get really big. So I'm gonna show you the ladder method again and how it works for LCM. 7 is a factor of both of these. It goes into 14 twice and into 21 3 times. There are no other common factors, so I'm gonna draw this L for LCM, and I'm gonna multiply all of those numbers in that L, just like I would multiply all the numbers in the G for GCF. 7 times 2 is 14. 14 times 3 is 42, which means 42 is my LCM. Okay, 29 and 24. So 3 is a factor of both of these. 3 goes into 9 3 times. 3 goes into 24 8 times. There's no other number except for 1 that goes into 3 and 8, so draw that L. Again, we multiply. 3 times 3 is 9. 9 times 8 is 72, which makes 72 our LCM. Okay, let's look at 21 and 22. Okay, 21, 26, and 39. So 13 is a factor of both of these. 13 goes into 26 twice, into 39 3 times. No other common factor there, so draw my L so I can multiply. 13 times 2 is 26, and 26 times 3 is 78. So 78 is our LCM. Last one, 22. 6, 12, and 14. Well, right away I see 2 as a common factor. It goes into all of them, and that's what I want to look for first. 6 divided by 2 is 3. 2 goes into 12 6 times, and 2 goes into 14 7 times. Now for LCM, I can pick a factor of just 2 of them. So 3 is the next number I'm going to choose. 3 goes into 3 once. 3 goes into 6 twice. And I didn't use the 7, so I just drop it down. Okay, this is the important step that some of us sometimes forget. So then I analyze 1, 2, and 7, my new factors. There's not another number that goes into just 2 of them. So I draw my L and I multiply. 2 times 3 is 6, times 1 is 6, 6 times 2 is 12, and 12 times 7 is 84, which makes 84 my LCM. Hope that helped. Bye.